Hello students, welcome to Dr. Shorab's classes. So as you know that we are solving this UPSC 2021 paper of mathematics optional, and this is paper 2 we are solving. So hope you have watched the previous videos where I have solved up to the 7b, question number 7b. So here we will solve the question 7c. This is the last part of the question 7. Show that this vector q, this expression lambda of minus y I cap plus x j cap by x square plus y square, where lambda is equal to constant, is a possible incompressible fluid motion. So determine the streamlines. Is the kind of the motion potential? If yes, then find the velocity potential. Okay, so that is our question. So we know that grad dot q is equal to 0. This is equation 1. Or we can write this lambda minus of del x y by x square plus y square plus of del y, it is x by x square plus y square. This is equal to 0. Okay, or we can write this as lambda is equal to 2 of xy by x square plus y square to the power square minus of 2 of xy x square plus y square whole square, that is equal to 0. So which is evident that thus the equation of continuity for an incompressible fluid is satisfied, and hence it is a possible motion for an incompressible fluid. Okay, so now we will write the equation of the streamlines are. So what will be the equations of the streamlines? So these are the dx by u is equal to dy by v equal to dz by w, or we can write this as dx by minus of lambda y by lambda y by x square plus y square, and this is equal to dy by lambda x by x square plus y square, and it is equal to dz by d. Okay, or we can write from here that x dx plus of y dy is equal to 0 and dz is equal to 0. So 0. Right, so by integrating we will find that if we do the integration, so that will give us x square plus y square, x square plus y square, this equal to a constant which I am giving equation 2, and z is equal to another constant, just a simple constant, you can say, that is equation 3. Right, so thus the streamlines of the circles whose center are on the z-axis. So if we draw a figure, and so you will see that, so this will be, so it will be, so figure will be like this. right? So this is our y, x, y prime and x prime, and here we have the, so here you can see that the streamlines are circles whose center are on the z-axis, right, and their planes perpendicular to the axis, perpendicular to the axis, right? So if we write this grad cross q, so if we write the grad cross q, so we will have, this is I, j and k, so simply we'll have this del of del x, del of del y, del of del z, right? And here it will be, you will have lambda y by x square plus y square, lambda x by x square plus y square, and it is 0. This is the cross product, right? Now del of this grad cross q, this is k of del x, lambda x by x square plus y square, plus of del y, so it will be lambda y by x square plus y square. Similarly, if we solve this, so grad cross q, we have this k of lambda, so this will be y square minus x square by x square plus y square whole square, right? And here it will be plus of x square minus y square by x square plus y square whole square, which is nothing but 0. Thus the flow is a potential kind, so we can determine the voltage potential. Okay. It is the flow is of potential kind. Okay. So we have this, so we can find the potential as this phi of xyz, where q is equal to minus of grad phi, right? Or we can write this del phi of del x, this is equal to minus u lambda of y x square plus y square. We give this is equation 4. Then del phi del y, this is equal to minus of v, this is minus of lambda x by x square plus y square, this is equation 5, right? Now the last one is the del phi del z. Okay, so this is equal to minus of w, which is 0. So that is equation 6. Okay, so which shows that the phi is independent of z, right? That is the conclusion. So that is our, it will be phi is a function of x comma y, right? So integrating this relation 4, we will get phi of x comma y is equal to lambda tan inverse x by y plus, it is a function of fy. So if we do the differential, this partial differential differentiation this with respect to y, differentiate with respect to y, then we will have this f prime y minus of lambda x by x square plus y square. Now using the relation 5, that is, we have this so this is integrating equation 4. Now using equation 5, so using equation 5 we get this f of prime y is equal to 0. So f of y is some constant. So from here we can write that phi of xy is simply lambda tan inverse lambda tan so we can write this. So phi of xy is equal to lambda tan inverse x by y. That is our solution to question 7c. Okay, so that's a solution to this question 7c. So we have to find the velocity potential and also determine the streamlines. So these questions are quite elaborative, as you can see, and because it carries it's quite this 10 or 15 marks. So in order to answer this question you have to explain each and this every step, and you have obviously have to do the sum correctly. That is only the way and that you can achieve through practice. So okay, so this there's the last question left, that is the question number 8. So we will come back with this video, this solving question 8 in the next.